Quick Electronics 101. How to use a capacitor. To begin with, we need to know what a capacitor is. There are a lot of different types of capacitors, and the most common one is this electrolytic capacitor. A capacitor is made of two metal plates with an insulator in the middle, and we call this a dielectric. It stores charge in its electric field between its metal plates. Basically, the purpose of a capacitor is used for storing energy. The ability to store charge in a capacitor is called capacitance. Can you guess what the units of capacitance are called? That is correct. It is farad. To explain it in the simplest way possible, just think of a water pipe with water flowing through it. Now, the water will continue to flow until we shut the valve. If we shut the valve, there will be no water flowing. But if we put a storage tank after the valve and we first let the water flow into the tank will store some of the water. And we will also have water flowing out of the storage tank pipe. If we close the valve, water will no longer pour into the tank, but we will continue to receive an uninterrupted supply of water at the end of the pipe as long as we do not completely empty the storage tank. In circuits, the capacitor acts as the water tank and stores energy. As a demonstration, we have here a 5V supply, a 330 ohms resistor, and an LED. After I connect the positive and negative supply, the LED lights up. Now, after I disconnect the power of the LED will turn off just like we expected. Next, I am going to connect a capacitor across the LED and the resistor, and then I reconnect the power and the LED lights up again. But take a look on what happened when I disconnect the power. The LED stays on, and after a few seconds, you can see that it is fading out. This is because the capacitor is like a tiny battery. When I connect the power, the capacitor charged up, and when I disconnected the power, it started to use its stored energy to keep the LED on. This is just one of the examples on how we can use a capacitor in our circuits. Now, how are we going to know the right value of capacitor to put in our circuit? Here we have a 2 LED circuit. The first LED circuit has a capacitor with a value of 25 volts and 220 microfarads, while the second LED circuit has a capacitor with a value of 25 volts and 4,700 microfarads. Take a look at what happened on both LED circuits when I disconnected the 5V power supply. As you can see, the LED circuit with a 4,700 microfarads capacitor takes more seconds before it is totally fades out. Compared to the LED circuit with a 220 microfarad capacitor only, it fades out faster. The voltage rating on a capacitor is how much voltage it can handle. So, you just have to make sure you don't have a capacitor with a voltage rating lower than the power supply you are planning to use. Meaning, if you have a 5V power supply, the voltage rating of a capacitor must always be the same or greater than the power supply. Because if you use a lower voltage rating of capacitor, it will typically lead to an explosive failure. For the farad value, it depends on the time you want it to take to fade out. Meaning, the higher the farad value means longer time, and the lower the farad value means shorter time. If you have no electronics component yet, you can visit Tinkercad.com and try to experiment with the capacitor there. And as always, keep learning and have fun. Bye!